What causes a hot air balloon to rise in the morning sky? The answer is density. The mass to volume ratio of the air inside the balloon is less than the mass to volume ratio of the air outside the balloon, and fluids that are less dense tend to float on fluids that are more dense. In the case of the air inside the balloon, the burners heat up the air and cause it to expand, as gases do when they're heated. Some of that air escapes out the bottom of the balloon, and the mass that's left inside the balloon is less than the mass of an equal volume of air outside the balloon. Welcome to Chemistry 1141 Laboratory Experiment 1, Prop 484 in your laboratory textbook. Relating mass and volume, density. Our Prelap topics today will be density, measuring mass in the laboratory, measuring volume, graphing and constructing a best fit line, variations in experimental procedure, safety, and waste disposal. Your laboratory instructors are going to spend an extensive amount of time with you talking about safety so that you're well able to take care of not only yourself, but your laboratory partner and classmates. First, let's define density and intensive properties. Density is defined as a ratio of an object's mass to the object's volume. Mathematically, we can express density as being equal to mass divided by volume, or simply D equals M over V. Intensive properties are properties that are independent of the amount of material considered. A few examples of intensive properties are color, boiling point, density, melting point, hardness, and temperature. I'll give you an example of an intensive property that you're probably familiar with. The boiling point of water at sea level is 100 degrees Celsius, whether you're talking about a cup of water or a gallon of water sitting on your stove so that you can cook your pasta. So an intensive property doesn't depend on the amount of material in question. That means an intensive property can be used to identify an unknown substance, which is exactly what you're going to do today. Let's talk about measuring mass in the laboratory. Before the actual experiment begins, your instructor will need to show you how to use the balances. I'll try and give you a little rundown on that now. This is a top-loading balance. It will record to 2 decimal places. First thing you'll have to do is turn the balance on. It'll take a few seconds to calibrate. And then what you'll do when you're measuring the mass of your unknown solid is you'll put a weighing boat similar to this, or perhaps smaller, onto the balance, but you've just added mass to the balance. So what you can do is press this button down here at the bottom of the balance, and it will subtract the mass of the weighing boat from the mass on the plate. That's called the tare button. So you'll take care of that, and then your instructor will coordinate the use of all the balances that are in the weighing room so that large groups of students are not in the weighing room at one time. Please be cooperative about this. 2 lab sections typically use the same balance room, so it can get crowded. People bump into each other and they knock each other's samples out of their hands. Then you have to start over. So cooperate. It's important that you keep these balances clean. They're expensive. Weigh only cool objects. These are electronic balances that are sensitive to hot objects, so only cool objects. Cleaning up any spilled materials is absolutely important. Not leaning on the balance tables when you're making your measurements, because that can, they're very sensitive, and that can affect the reading that you get for your mass. And any other usual precautions observed with balance use. Ensure that you keep the weighing room clean, dispose of any garbage, don't leave any paper, powders, or any unknowns lying around. Use the same balance throughout your laboratory experiment. That is the best way to guarantee the consistency of your mass measurements. If you misuse the balances, that will result in a dismissal from the lab. So let's get down to actually weighing your sample. The first thing you need to do, for sure, is to make sure that your sample is absolutely dry. Water has weight, considerable amount of weight, so we don't want a wet sample. Here we have the top loading balance. The weighing boat has already been placed on the platform and the balance has been tared. You can tell that because it's zeroed out. And we're going to go ahead and we're going to weigh a sample. And we're going to weigh it to 2 decimal places. We're going to be very careful. So that's our second sample. We're at 6.01 grams, which is good mass for that particular sample. Although the laboratory experiment indicates that each mass measurement should be made 3 times and averaged, you really don't need to replicate the measurements as long as you're careful with each individual measurement. Therefore, the single measurement can be used as the average mass. That's a variation on the procedure. Measuring volume. The volume of the sample will be determined by the volume displacement of water in a graduated cylinder. Read the volume on the graduated cylinder at the bottom of what is called the meniscus of the water. So here you can see I've got approximately 4.1234, and let's say so that's 4.4 milliliters of water in this graduated cylinder. And I want to get right down eye level with the bottom of the meniscus when I'm reading that graduated cylinder, and read it to 2 decimal places. Here I've got a little video showing me loading the graduated cylinder, and the way you want to load this graduated cylinder is using a funnel. And you use the funnel to make sure that you don't lose any of your sample. You also use the funnel to make sure that you don't splash any water out of your graduated cylinder, which would reduce your volume and give you an improper measurement, an inaccurate measurement. So there we go. We're doing that. You're going to have air bubbles in your sample, and that will result in significant errors because those air bubbles do have volume. So you're going to want to shake the mixture a little bit to remove things like this, air bubbles that you see trapped in the graduated cylinder. You should not place the 10 mil graduated cylinder when you're done on the pegs of the drying rack. The graduated cylinders have a diameter similar to the pegs, so that's a big no-no, guys. What you'll do is you'll expand the volume of our graduated cylinder and render them useless, so don't be doing that. Although the laboratory equipment indicates that each volume measurement should be made 3 times and averaged, just like the mass, you do not need to replicate the measurements, just do it once. Therefore, the single measurement can be used as the average volume. Now we're going to talk about graphing. You need to construct a freehand graph. You have graphing paper in your laboratory notebook, and you'll be plotting the volume in milliliters on the x-axis, the mass in grams on the y-axis. You need to label both of the axes. On each axis, make the divisions equally spaced and well marked. That should be easy on the graph paper. It's unlikely that the points will fall on the straight line because there's always error involved in each individual measurement. Therefore, you need to draw what we know as a best fit straight line that minimizes the distance of all points from the line. That averages the experimental error for any single measurement and reduces the total amount of error. The slope of the line is equal to the density of the material. The slope of the line is expressed mathematically as the change in y with respect to the change in x, or the rise over run. You'll have to select 2 points along your best fit line. Make it clear that the points you select may not and probably are not one of the points you measured directly. We don't want you to use those points. Take individual different points from the line, the best fit line that you draw. For example, if the 2 points were x sub 1, y sub 1, 3.80, 5.28, and x sub 2, y sub 2, 1.10 and 1.40, then the slope of the line would be calculated as m. M is the symbol that we always use for slope in algebra. Y sub 1 minus y sub 2 divided by x sub 1 minus x sub 2. You could also do this as y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, as long as you're consistent with your y values and your x values. You'll get a positive value for your slope, which will reveal your density for you. So here you can see that calculation. You'll need to be consistent with, as I said, those x and y designations in order to get a positive number for the slope. So here is an example of a nice set of data. You can see we've got 2.94 grams on the y-axis. On the x-axis, we have the volume of 0.35 milliliters, and we have 5 individual points that we have now drawn a best fit line. And the best fit line doesn't necessarily connect the dots. What it does is it minimizes the distance between any individual dot and any other dot. It's what is called a best fit line. Then we simply select 2 points on the line, calculate the change in y with respect to the change in x as previously demonstrated, and that's the density of your substance. The experiment indicates that you should select 5 different samples of each unknown. However, the unknowns are going to be metal shots stored in beakers. Each beaker should contain approximately 50 grams of unknown. So to be clear, you'll have one unknown from which you will extract 5 different samples of different masses. You'll measure out the samples of the unknown with approximate weights of 3, 6, 9, 12, and 15 grams. Now, you don't have to be exact with the weights. However, make sure that you record all of the digits displayed on the balance. For example, many students will write 3.1 grams instead of 3.12 grams. Make sure that you write down your unknown number before you start your experiment. So here is one particular sample. This is the 12-gram sample, and it was weighed to 12.12 grams. And then we have another sample. This is the 15-gram sample, and it's at 14.81 grams. You don't have to be exact. You should be close, and you record to 2 decimal places. In order to determine your displaced volume using the water in the graduated cylinder, fill about 1/3 of the graduated cylinder with water. Read and record the volume from the bottom of the meniscus. When you add the solid, do so carefully to avoid splashing water out of the graduated cylinder. You'll need to cover the solid completely with water. So here we've filled up the graduated cylinder to, looks like 4.4 milliliters. Now we're going to go ahead and add our sample very carefully to avoid splashing. And you can see that the sample has displaced a considerable amount of volume. You'll want to go ahead, by the way, and knock out, shake the graduated cylinder, get some of those pesky bubbles out of there before you read the bottom of this meniscus. But in any case, the bottom of the meniscus says that we're right at about 7.20 or 7.21 milliliters. Now let's talk about the most important thing that we can think about in the laboratory, and that is safety. First of all, make sure you're wearing your safety glasses, appropriate clothes, and follow all the safety rules and precautions. If you fail to follow the rules, you will be dismissed from the lab and you'll be sent to the laboratory coordinator before you can get back into the lab. Now, the lab can be a dangerous environment, so it's very important to be aware of your surroundings, aware of what other people are doing, and to be careful in how you conduct yourself. Make sure that you're aware of all the safety equipment and the location of each piece of equipment. So for instance, here is the emergency fire blanket, which would go around somebody who happened to be on fire. We're trying to minimize the possibility of that, but every laboratory does have a fire blanket in it. Your laboratory instructor will give you some more detailed instructions on how to use the fire blanket, as well as the fire extinguisher. We'll do a little demonstration of exactly how the fire extinguisher works. This is a very important piece of safety equipment. This is the eye wash. Should you get a chemical spill in your eyes, you will spend 15 minutes under the eye wash flushing out your eyes. Someone will watch the time for you. We'll also call the paramedics, have them check you out, and make sure that you are okay. You may wind up with a trip to the hospital, depending on how bad the spill is. We take splashes in the eyes with chemicals very, very seriously. This is the safety shower for major body spills. Most of the time, if you just wind up with chemical spills on your hands or on your lower arms, you can handle that in the sink. and do a flush. Again, it is 15 minutes on the clock, flushing out your hands, your fingers. But if you wind up with a major body spill, this is the place to go, and the laboratory instructor will talk about the scenario should that happen to you. Waste disposal. When you have completed the laboratory experiment, please drain off the excess water of your sample. Place the samples back in the unknown beaker and the beaker in the oven while you're performing the calculations and constructing your graph. Here's a picture of the oven so you know exactly where it is. It's on the back bench in the corner. Cleanup. Take responsibility to make sure that your workspace is left clean for the next chemist, because the chemist before you did exactly that for you. And if someone's not cleaning up the lab, we do want to know about it. So here's a nice clean bench, all chemicals and any tools, any glassware have been cleaned, dried, and put back in the bins. So no glassware should be left wet on the back bench. Dry everything, return it to the bins. Here's the back with the drying racks. Please leave the lab in a clean and orderly condition, and that also means the balance room. Very often the balance room will be neglected, and the next lab will come in and they'll have a dirty balance room. That's not acceptable. Make sure you clean off the benches, clean off the balances, and leave it in very tidy condition.